So my name is Ifeoma Okereke. Today I'm going to be talking about building smart applications, building smart cross-platform applications with Flutter and ML Kit. I am currently an Android engineer at WW, formerly known as Widgets, and I work on the Android app. Most recently worked on rewriting the authentication flow of the Android app. So let's get started. So these are the objectives of the talk today. It's going to be in two parts. The first part, I'll talk about Flutter, introduce Flutter widgets, and then we'll explore a Flutter demo application. And then the second part of the talk, I will introduce ML Kit, tell you what it is, and we'll explore the APIs that ML Kit has available. Okay, so by show of hands, who here is familiar with Flutter? You've either run the sample app code or written code by yourself or just heard about it? Okay, who here is hearing about Flutter for the first time or like, okay, that's great. Okay, so it's good because this is kind of like an introductory talk to Flutter, so I like the mix. So what is Flutter? Flutter is Google's mobile SDK used to create beautiful native interfaces on both iOS and Android from a single code base in record time. So you will use Flutter, it's a cross-platform development tool. You will use it to build your iOS app and your Android app. And the great thing about it is that you wouldn't have to maintain two different code bases. You will have just one code base, and that's your Flutter code base written in Dart. Why do I like Flutter? What is great about it? The first thing that I really like about it is that it allows you to do fast cross-platform development. So since you can develop Android and iOS apps, you don't have to manage both apps, and you can just say, oh, I need to release this new product. I can just write it in Flutter and release it to both your iOS and Android users. The second thing about it is that you build performant native interfaces. If I showed you an application today that's built with Flutter, you wouldn't know that it was built with Flutter. You would think it's a native Android or a native iOS app. And that's really, really nice about it. It doesn't look like a web view, and it doesn't look clunky at all. It's very, very native. One other thing that's great about Flutter is that Flutter has a lot of built-in widgets, and it's not limited to the OEM widget. It doesn't even use the OEM widgets. The OEM widgets are the widgets that come with the device. So, for example, you have your text or whatever UI that your phone provides. If you're an Android application developer like myself, you know that a lot of times you have Android apps have headaches because of Samsung. Samsung like modifies the Android operating system code and causes issues with your apps. But with Flutter, you wouldn't have to deal with that because Flutter has its own built-in widgets. And we'll talk more about that in a second. Flutter also provides you with platform-specific code where needed. So if you have some platform code that you need, so maybe like you need to communicate with a Bluetooth, or you need a separate behavior on Android and iOS for the same feature, you can do that with Flutter. It also supports Android Jelly Bean, so API 16, and iOS 8 or newer. There's this also really nice feature called the hot stateful reload. And hot stateful reload it just means that changes to your running app are seen in less than a second. So if you've done any bit of like mobile development before, you know that when you run the app, it could take anywhere to like 5 to 10 minutes or more for you to install the app and see the changes on the phone or on the device. But with Flutter, once the app is installed on the device, you can just make a change and then you see it in less than a second. This is like one of the things that's really, really exciting to me. So I'm going to show a demo of that so that you get an idea of what I'm talking about. So this is the sample app that comes when you create a Flutter application. What it does is that when you click on the plus button, it increments the count. And that's all it does. Click on the plus button, and it increments the count. So here I am, let's see, it's meant to play. Okay, yes, not seeing it here. So I changed the color to pink, and you see that the change appeared there immediately. I incremented the count, and I'm changing the title to, what did I change it to? Philly E2E demo. And then when I hit hot reload, which is cut off, it appears immediately. And then if I want the count to decrement instead of incrementing, I can change the code and then hit hot reload again, and then it decrements. So that's really, really cool because I don't have to run the app and waste 10 to 15 minutes just to see the change that I'm looking for. Can you tell whether these apps are native apps or Flutter apps? Are you able to tell? So all these apps are built with Flutter, and as you can see, they're very smooth, and the animations are smooth. The widgets look so very native, and everything looks native and custom. That's one of the great things about Flutter. You can't tell that this was built in Flutter, but it was. All right, so let's talk about how you get started with Flutter. The first thing that you need is you need your IDE. I use Android Studio, but you can use IntelliJ, you can use Visual Studio Code. If you also want to use the command line, you can do that. Flutter provides you with the tools to just set it up with the command line, and then you can run it to your app. You can edit it with your favorite text editor. You can do that. And then the next thing to do will be to download your Dart and your Flutter plugins. Download the Flutter SDK, and then create a Flutter application. So I'm going to walk you through an example of this in Android Studio, because that's what I use on a daily basis. So on this screen, I will select start a new Flutter project. And then when I hit start, I'm going to be presented with this screen. Because for the purposes of this talk, I'm creating a Flutter application. And a Flutter application is just a regular app. It's different from a Flutter plugin or package or module. So we're going to focus on just creating the Flutter application. So once I hit next, I can fill in my details of the app name and the project name. I can set the package name and then hit finish. So once I hit finish, this is what I get. Excuse me. So I have my project structure on the left, main.dart in the middle, and then the sample application. So this is your sample application. For some reason, I'm not seeing it playing here. But yeah, so you see that once I tap on the plus button, it increments the count. So that's the sample application that comes with Flutter. So to the left, it shows me my project structure. So these are the folders that you will see when you create this application. You have, aside from the Gradle folder, you have Android, iOS, lib, and test. And in the middle is my main.dart code. This is where I'll write my code. So this is where I'll write the code for my app. So this just shows you the structure that I mentioned earlier. You can ignore the IDE folder, but we have Android, iOS, lib, and test. My Android folder shows me the contents of my Android app. So if you were going to create an Android application with Android Studio, the contents of this Android folder look at the same as the contents of the application that you created with Android Studio. So it's pretty much the same content. You can open this folder in Android Studio as an Android application by itself. You can add code to it if you want. And then iOS is the same as well. You can open this iOS application using Xcode. And in your lib folder has your Dart code. So Dart is what you'll be writing code in. Is a programming language that you'll be writing code in. And the test folder this is where you keep your test classes, your widget tests, unit tests, and all that. And then your pubspec.yaml file is for your dependencies. So you have your image assets here, your custom fonts, your app name, and whatever other configs that you need to set up for your Flutter app goes inside of the pubspec.yaml file. Okay, so before I go forward to before we go and explore the contents of main.dart, I'd like to talk a little bit about widgets. So widgets are the basic building blocks of a Flutter application's UI. So in Flutter, your widget can be a structural element like a button, it can be a padding, it can be center, it can also be a navigation component. This is one thing that I had to learn coming from the an Android background, that everything was a widget, or almost everything in Flutter is a widget. So your widget is, if I needed to add a text to the screen, that text is a widget. If I needed to center that text in the screen, the center thing is a widget. If I need to navigate to another screen, the navigation component is a widget. So almost, not everything, but almost everything is a widget. So we need an understanding of widgets. There are two kinds of widgets. We have the stateless and the stateful widgets. It's just the difference between it is that one can change and the other can't. So if a widget can change, it's a stateful widget. If it can't change, it's a stateless widget. So I'm going to show an example of stateless and stateful. So on this slide, I'm showing you stateless widgets. The top shows a text view that says stateless widgets. In the middle, I have icons, and the bottom is a button. So these widgets, they don't change. They just display whatever data or whatever content they have to display when the app was initially built. For the stateful widgets, they are dynamic, and they change in response to change in data or user interaction. So in this example, I am showing a checkbox. A checkbox is a stateful widget. It can change when you tap on it. It can be checked or unchecked. And then the slider at the bottom of it changes value as I move the slider. So I'm showing the change in value as it moves. And then this is a text form field that I can just enter whatever text that I need to enter. And it remembers the text. I can clear it as well. And it remembers that I cleared it. So that's mainly the difference between stateful and stateless. One is dynamic, that's the stateful, it can change, and then the other is not. Okay, so let's go back to our main.dart file. So this is what we created initially. I just modified it a little bit. In this application, I'm showing in the center of the screen, I'm showing a text, 32, and at the bottom right is a floating action button. So what it does is that when I tap on the fab, it increments the number. So I just want to explain, just highlight a few things that stood out to me when I was looking through this code for the first time. So this is the main function in Flutter. It's the entry points to your Flutter application. So this is the first function that gets called when your Flutter application is run. And the function, this is just like, this is a one-line function that just says run app, and the inputs to it is my app, which is a widget. So run app takes in a widget, and run app just says inflate the content of this widget and attach it to the screen. So run app is going to inflate my app, and it's going to attach it to the screen. And my app is a widget, as you see shortly. So this is the code for my app. My app is, in this case, it's a stateless widget. It can also be a stateful widget, but for this example, it's a stateless widget. And and if you notice that there is a build function that we're overriding, a build function is where your widgets are created. So you can compose your widgets in the build function. This is what's called when the state of the app is initialized. So in my build function, I'm creating a material app. A material app is an application that uses material design. It is a stateful widget. This material app has a title called Flutter Demo. It has a theme that I already set to pink. And then it has a home page. This home is used to create my homepage widget with a custom title. So in this example, I set the title to Philly ETE Demo. And as you can see, the title is like displayed on the screen. So let's see what my homepage contains. So as you can see here, my home page is a stateful widget. And if I go back to the previous slide, you see that my app is a stateless widget. My home page is a stateful widget. And if you can see the difference between the two, I'm overriding two different functions. The first one, I'm overriding a build function, and the second one, I'm overriding a create state function. So the create state is actually the function that creates my widget state, just like the method name says. So inside of create state, I am creating a new instance of my homepage state, which we'll see in a moment. So this is my homepage state. This is all the code that powers the screenshot, the app screenshot that you saw earlier. So if you notice, my homepage state also has a build function. It has a count. In this example, we have a count. If for your use cases, you can have whatever you want that needs to change. Since this is a state, it can be a text, it can be whatever that needs to change. And then I have a function that increments the count. So notice, like in my increment count function, there is a set state. And set state is called when I increment the count. What set state does is that it notifies the framework, the Flutter framework, that the internal state of this widget has changed. So when it says, hey, my internal state has changed, you should schedule a build for this state object. So when set state is called, the Flutter framework redraws the view again on the UI, so you see the change. And then this is my build function that creates my scaffold widget. The scaffold widget is just a stateful widget that implements a visual material design visual layout structure. So let's look at it in more detail. My scaffold has my app bar that I highlighted at the top, and with the app bar, that's where I set the title of my app. It has the body. In this case, my body is just 2 widgets. So you can see what I was saying earlier, that in order to center text, I would need a widget. So in this case, I'm using a center widget, and I'm using a text widget. So the text widget just displays the count that I'm incrementing. And because I wanted the text to have a size, the big size, I chose the font size of 100, and I wanted it to be bold. Excuse me. I wanted it to be bold, so I set the text style to that. If you want whatever it is that you want for your app, whatever it is that you want your app to show, you would set it in the body section. For this app, I just have a center and a text widget. It's just those two. And then at the bottom right, we have the floating action bar. And when you tap on the floating action bar button, it calls the increment count function in onPressed. So it calls increment count, and that, I'm just gonna go back here. This function is what gets triggered when you tap on it. So yeah, that's pretty much it for our demo application. So Flutter is a cross-platform framework. It is not the first one. I don't know if it's going to be the last one. But I would like to show how it compares with existing cross-platform solutions. So before I start that, I'd like to show you how a native application looks. The native application, for your native application, you have, like, on your app, the green side is your app, and the blue side is the platform. So your native app, your app communicates with the platform widgets, and the widgets are rendered on the canvas, and they pass back, the widgets are rendered on the screen canvas, and the events are passed back to the widgets. So the app communicates to the widgets, they're rendered on the canvas, and whatever events that are available are passed back to the widgets. The app can also communicate with the platform services. So if you needed location, Bluetooth, or any other information that's a platform service, your app can communicate with them directly. The downside of this is that like I mentioned before, you need, since you have, you need both Android and iOS, you would need to maintain 2 separate code bases. So let's look at the next one, a web view application. So this is like your PhoneGap or Ionic or Apache Cordova, the app that creates HTML content and displays it on the platform web view. So your app is running JavaScript, but it's communicating to the platform web views, and that gets drawn on the canvas. Events communicate back to the web view. But if the app needs to access or speak to any of the platform services, it needs to go through this JavaScript bridge. And this JavaScript bridge is going to cause your app to take a slight performance hit because like it's communicating through a bridge to go talk to the services. Then for your reactive application, reactive applications like React Native, your JavaScript code communicates through this bridge to the platform widgets and also to the platform services. And so whenever it has to go through this bridge, it takes a performance hit as well. So let's see Flutter. So with Flutter, there's no JavaScript bridge. But what happens with Flutter is that the widgets are moved into your app, and the rendering engine is also moved into your app. So, and the platform channels are also moved into your app. So when you're communicating with the platform, you don't even use the platform widgets. So yes, there will be platform widgets, but you don't use them. You just communicate directly to the canvas, and your widgets get drawn on the canvas. And the same thing with the platform services. Your app communicates through the platform channels to the platform services. So because Flutter doesn't have that JavaScript bridge, it's more performant, and there's minimal cost in communicating with the platform. All right, I'm sure you're thinking like, yeah, Ifeoma, Flutter is so great. You said a lot of nice things about it. There has to be some cons to it, right? So yes, there are, depending on how you look at it and depending on what you want to accomplish. One of the cons for me is that it is actively being developed. Yeah, so even though it's like they've already released like version 1.5.5, it is being developed actively. So that means there's the good and bad sides to that. It means that I can pull the latest version and get the latest changes, but that could potentially break my build or break something that I'm working on. It also means that they're like working on making changes regularly, so I'm gonna get those changes. Just yesterday when I was like testing out sample code, I was like, yeah, let me just do Flutter upgrade and just upgrade. Of course, well, it didn't work for like the next few hours. I had to debug and figure out what was wrong. So like that's like one of the cons to it. But I really like to stay updated. So this is a screenshot that I got of the Flutter repo on GitHub. If you can see like the frequency at which they release updates. Just 2 days ago it was 1.5.4, and now 21 hours ago they released a new version. So like they're releasing updates frequently. Another con is that for a simple, bare bones, hello world application, the minimum APK size or the iOS app size would be, for the iOS side, it will be 10.8 MB, and for Android, it will be 4.08 MB. And if you're curious how that application looks, it's just this. It's one line of code that just says hello world, but it's going to be big on your phone. So if you're considering Flutter, you have to put that into consideration and say like, okay, I have to be aware that my app size is going to be this large initially. And the reason it's this large is because I showed earlier, Flutter bundles the widgets and the rendering engine on the app. So that's why it reflects in the app size. All right, in summary, we explored an introduction to Flutter. I told you what Flutter is. I told you what's great about it. We looked through the Flutter demo application. I talked about widgets, the stateless and the stateful widgets. I talked about how Flutter compares to other cross-platform solutions, and I also talked about the cons of Flutter. So now you're probably wondering, yes, this is Flutter and ML Kit. Where's the ML Kit part? It's coming, don't worry. The way to build a smart application in a really easy way is to use, one of the really easy ways to do that is to use ML Kit. Machine learning is something that I'm still learning, something that I'm really excited about, but I wanted to try my hands on like machine learning models that I didn't build that would show me how cool machine learning can be. So that's where ML Kit comes in. So I started playing around with ML Kit. ML Kit stands for Machine Learning Kit. It is provided by Google via Firebase, and it provides pre-built and custom machine learning models for a variety of use cases. So you can have your machine learning model for detecting a barcode or detecting faces in an image or whatever use case, it provides that. And it's cross-platform, so it's available on Android, iOS, and Flutter. And this Flutter that I'm going to be talking about today. It also runs on device and on the cloud. And if you're running it on the device, it's free. But if you're running it on the cloud, it's partly free. So it's free for like the first 1,000 users, and then after that, they start charging you. So let's explore the different APIs that we have. So these are the APIs we have currently supported on Flutter's ML Kit library. You have image labeling, barcode scanning, text recognition, face detection, landmark recognition, and custom models. For the purpose of this talk, I'm just going to focus on the first four because the library is still being actively developed. So landmark recognition and custom models are not ready yet, so I didn't explore them. So the gist of ML Kit is that it takes in image data, so that could be your image, your video, or your camera feed. And then it takes in an image and outputs image data. So you can send in an image, let's say an image file, or you can set it up with your camera and just like send the camera feed through the API. And then it sends you back what it thinks the image contains. So for the first one is the image labeling API. Like the name says, it's used to recognize images it recognizes entities in an image without providing additional context. And what entities is people, things, activities, places, whatever it is that's in the image, it recognizes that without you providing additional context. So what you do is just send the image and it tells you what it contains. And this is really useful. It can be used for like metadata generation or content moderation. So if you want to restrict like the images that are shared in your application and say, oh, I don't want certain content to be in there, you can use ML Kit to say, if this user's image has this, don't allow them to upload it, something like that. It's also free. On device, I mentioned this earlier, it's free on device, and on the cloud, it's free for the first 1,000 users. Why would you need to use it on the cloud if it's free on the device? So the reason that using it on the cloud is good is because the cloud is more accurate, and it provides you with more accurate results for the images that you send through the API. But for the free one that's on the device, you can still use it. It still provides you with some results, but not as accurate. So in this example, I used this image with the image labeling API, and these are the responses that I got from the API. As you can see, not all the things that are in the response are actually in the image. I have a flower pot. I have a phone. I don't really have a TV, but it kind of looks like it's because it's a screen. But What the image labeling API returns is the labels and a confidence ratio. The confidence ratio is a ratio between 0 and 1 that just tells me, that tells that the ML model uses to tell me how confident it is that this image contains that label. So in this image, it's telling me, oh, I'm very confident that it contains a flower pot. I can use this confidence ratio to say, oh, only return to me labels that are over 0.5, for example. And then if that's the case, it's going to return only the mobile phone, the desk, and the flower pot. OK, so let's see some code. So this is the code that I use to generate that. It's just 3 lines. But before generating this, you would need to I already added my ML Kit library to my pub/spec file. In the first line, I'm reading my image from a file. I mentioned earlier that you could have like a video stream or a camera, or you could just read it from like the string path. So it doesn't have to be a file, but in this example, I'm using a file. So if I was reading from a camera, I would read from bytes, or from a path, string path, I would just specify the path there. And then when I get the image, I call the label detector in the second line, and then I use the detector to detect the image in the image file. And because it runs in the background, I have to use, it returns a future list of labels. And if there's nothing that it detected in the image, I'm saying return an empty list of labels. So this is what the label class looks like. So I mentioned earlier, it has a confidence ratio, it has a label, and it has an entity ID. The confidence ratio is saying this is how sure I am that this image contains that label. The label is just the name of the label. Then the entity ID is the Google Graph Search ID for that label. Okay, that's it for image labeling. For face detection is used to detect faces in a video or in an image or in a camera stream. So face detection is so very different from facial recognition, which can differentiate between two faces. But this one just says, yes, there's a face. No, there's not a face. And it only detects human faces, not animal faces. So if I take a picture of this room, it will return to me all the faces that it detects. It is also able to identify the key facial features. So it'll identify your eyes, your mouth, your ears, your nose. So for every face it detects, it tells me this face has an eye, or has eyes and nose and all that. And it can get the contours detected on the face. So your contour is like the lines, the bounds around the facial features. So the bounds around your eyes, or the bounds around your eyebrows, or your mouth, or something like that. It can also recognize facial expressions. So if I was smiling and I use the facial detector, it'll send a probability back to say, oh, this is the probability that shows she's smiling or not. Or if I have my eyes closed, it'll also tell me whether or not my eyes are closed. You can also use it to track faces across a video frame. So if I was to have my demo app and just go through this and take a video of it, it'll tell me, I can track one face as a face moves in the video. So here's the code for it. It's the same as the previous one. It's also 3 lines. And this one I already have my vision image, but I'm calling my face detector, and I have certain options that I set for it. So the first line says I have my detector options, and I have classification enabled, I have landmarks enabled, I have tracking enabled, and I have set the mode to accurate. So the reason I set the mode to accurate is because I want it to give me the most accurate result. The other option is to set it to fast, which will be fast, but it would not be as accurate. And enable tracking, that just means that, I mentioned before, you can track faces in a video stream, so it's just, I'm going to track the same faces. Enable classification is used to determine whether a certain facial characteristic is present. So are your eyes closed? Are you smiling? Are your eyes open or closed? And then the same as before, I will detect the image, the faces in the image, and it returns to me a list of faces. So it returns a list of faces, and inside of my face, I have the bounding box. The bounding box is just a rectangular coordinates that shows where the face is in the picture. The landmarks are like shown on the left, landmarks on my left eye, right eye, and the position. And then, as I mentioned earlier, it'll tell me, is my left eye open, is my right eye open, and like it returns the probability of that and returns the probability of whether or not I'm smiling. So that's it for face. Let's go to text. So text recognition is used to recognize text and images, and it's available on device and on the cloud. As before, for the on-device text recognition only supports Latin-based languages. So if you want the support for other languages, you would use the on-the-cloud text recognition API instead. So this is like very useful. You can use it to automate your data entry task. You can use it to extract text from images. And you can use that. So let's say you have an image that's in Chinese, for example, and you use the text recognition API to get the text out of that image. You can also use, once you've gotten the text, you can translate it and display it, overlay it back on the image in English. So you can use that to translate from one language to another. There are other varying use cases for this. So it's the same as before, just 3 lines of code. You get the vision image, read it from a file, and you detect the text. And you get the text recognizer, and then you detect the text in the image. So it returns you a vision text, which you'll see in the next slide. So vision text contains a text and a text block. What a text block is just a paragraph. Example, a paragraph, and inside of the text block, you have text lines. So a text block is a paragraph, a text line is a line. And in the text line, you have text elements. The text elements are words in this paragraph. And then in the text element just shows you the text for each word. So that's interesting because you can decide that you want it to maybe highlight a paragraph or maybe highlight a line or something, or just play around with it in different ways. You can do that. Okay, so I'm going to go to barcode scanning. Barcode scanning, like the name implies, it lets you read data encoded for using most standard barcode formats. So in this, the API supports linear formats and 2D formats for most standard barcode formats are supported. And it works with any image orientation. So what happens is that as before, you send in the image through the barcode scanning API, and it returns to you a list of barcodes. The same similar code as before. So it returns to you a list of barcodes, and this is what the barcode looks like. It has the value type. So the value type tells you what type of barcode it is. Is it Wi-Fi? Is it contact information? Is it phone number? What's the content of the barcode? And then it returns the bounding box. The bounding box is the same as the other APIs, where it just shows you the box around where the barcode is in the image. And then the raw value is the value inside of the barcode. So if it's the numbers at the bottom or numbers that the barcode is encoding, the raw value will have that. So that's it. So let's see landmark detection. landmark detection, even though it's not available yet in the ML Kit library, it's available on Android and iOS, though it's just not available on Flutter. It's used to detect well-known landmarks in an image. So what it provides is that the name of the landmark, its geographic coordinates, and the region of the image that the landmark was found. So let's say what's a popular Philly location?
Art museum.
Yeah, the art museum. So let's say I went there and I took a picture and I passed it through this landmark detection API. It'll tell me back, it will return it back to me and tell me it thinks this is the art museum. And it'll also send back the geographic coordinates of that art museum. And then it'll send back the bounding coordinates, bounding box of where in the image the art museum is. And then let's say that you've seen all of the machine learning models that are provided by Google Firebase, and none of them fits your use case. You want to build something that's more complicated or way cooler or whatever. You want to build something else. You can do that with custom models. So all you need to do is create your model with TensorFlow Lite, and you need to host your model using Firebase, package it in your app, or package it in your app. So the difference between hosting it via Firebase and packaging it in your app is that if you package it in your app, your app size is definitely going to be larger. Your users would download that, and if you need to update it, you need to update the app so they can get the updated version of your model. But if you host it using Firebase, you wouldn't have to have like the larger app size, and you can update the app and dynamically, and you can update the model, and the users wouldn't have to update the app to get the latest version of your model. So once you're done creating your model and hosting it, you would use the ML Kit SDK to perform inference of your custom model. So it'll provide you with an API so you can read and use your model on the app. Okay, so in summary, we talked about ML Kit APIs. We explored image labeling, barcode scanning, face detection, text recognition, landmark detection, and I just highlighted a few things about the custom model. I also talked about Flutter, introduced it and talked about widgets, and told you why I think Flutter is great and why I think you should use it. I talked about the cons of using Flutter if you're considering it. So here are some resources that I think are good that helped me when I was starting out. One of the nice things about Flutter is that it really has really great documentation. So apart from the documentation in flutter.dev/docs, you can command click into a class and use a widget or whatever class that is in the IDE, and you see like very detailed documentation on how it works, and that really helped me get up to speed. There's also Flutter for Android devs, Flutter for iOS devs, there's Flutter for React Native devs, or Flutter for people coming from the web, so to help you understand how Flutter works if you're coming from that framework. And then there's the Udacity Flutter course I took. It's very useful to get you up to speed in building a Flutter application. There are also the code labs. The code labs are helpful. I took a number of them. And then this is the ML Kit library if you want to follow along for the updates to the library. All right, last but not the least, we're hiring at WW. If you want to work with me, we have New York, San Francisco, and Toronto offices. Just go to www.com/careers. Yeah, that's it. Thanks for listening. I think I'm going to take questions. So somebody asked, what are the advantages of Flutter over React? I already covered that on the slide. I don't know if I should still answer it. But the advantage is that for Flutter, in the image that I showed, maybe I should just bring up the slide. In the image that I showed here, this is like an example of a React application, and this is the Flutter application. So for the React application, it goes through a bridge, a JavaScript bridge, every time it needs to communicate with the platform widgets and the platform services. For Flutter, it doesn't have that JavaScript bridge. Instead, the widgets and the rendering engine are on the app, and the platform channels are also on the app. So it has a downside of making a bigger app size, but it doesn't take a performance hit because of the bridge. Some of the ML Kit features appear to be the same as IBM Watson's service. Are you aware of any comparisons between the two? So I haven't worked with IBM's service. I can check, but I haven't actually taken a look at that. How would you convert a current native application to use Flutter? So I wouldn't take the approach of converting a native application. Flutter lets you keep your native application and add Flutter components to it. So you can, if you want to go ahead and convert it, go ahead. You just have to write the code from scratch. But if you don't want to do that, you can keep your native application and then have a separate part of the app that is in Flutter that you just integrate into it. So that's the good thing about Flutter. You can have part of the app in Flutter and part of the app native. What is the current community support? The community support is very, very great. So it's not just Stack Overflow. There is, I think it's called Gitter, and there are also like issues on the Flutter GitHub repository that you can create, and they get addressed really quickly. So yesterday I was talking about when I was building my application, and I ran into some issues that I just spent like 2 to 3 hours trying to debug. So I went on GitHub and I saw like some issues and some suggestions on how to fix the issues. So they have a very, very supportive community. They have like very supportive developer advocates that are available if you want to reach out to them. How does Flutter compare to, how does Dart compare to JavaScript? I'm not sure of the answer to this one. Compare in terms of like performance or, I'm not sure about this actually. There are 2 different languages. I know that Dart is, one of the reasons that Dart got chosen for Flutter is that it has support for ahead of time compilation and just-in-time compilation. So your Dart code gets compiled ahead of time to ARM code that the phone understands. And the just-in-time compilation is what hot reload uses. So, but I'm not sure about the answer to this question. Does app scale as a normal native app would?
I totally messed that up. What I meant to say is, although the small base is quite large, would it scale at the same rate that an Android app would, or does that allow? So if I had an app that was like 20 megabytes native Android, what would be a comparison? Would it be just as much, or would it be more, or would it be less as the app gets bigger and bigger and bigger?
So I haven't experimented with that, but I imagine that it would be my normal Android app size plus the minimum size that takes care of like the widgets, the rendering engine, and the platform channels that's bundled in the app. So I imagine it's going to be like a similar thing, but plus 4 MB. Yes. When an app uses ML Toolkit, does the device need an internet connection for the app to use the ML features, or does it depend on the feature? So yes and no. I mentioned that you can have the on-device and on the cloud versions of ML Kit. So if you're using the on-device version, you do not need an internet connection. You can just use it and it works. The downside of using the on-device version is that it's not as accurate as on the cloud one. So for the image labeling example that I showed you, it'll be more accurate if I use the cloud one than if I use the on-device one. But you can definitely use it without an internet connection. So if you add a Flutter component to a native app, does that automatically add 4 to 10 MB to your APK? I would assume that it does. I would assume that it does because the Hello World bare bones application I showed earlier was 4 MB, so I assume that it does. Do you need to install Android and iOS SDKs in addition to Flutter SDKs to generate the native binaries for those platforms? Yes, that's one thing I didn't mention. So if you're installing, because I already had Android Studio installed, I had the Android SDKs, and I already have Xcode installed, so I had all those. So yes, you need to install both of them. In addition to the Flutter SDK. And it's good that you get to install both of them because sometimes some libraries that you need are not available in Flutter, so you can just write it natively. So yeah, so having both is good. Are you excited for Google I/O for the Flutter and ML announcement? Yeah, I am. I am very excited. I'm going to be at Google I/O in 2 weeks. Yeah, I'm super excited about it. So thank you so much. I really enjoyed speaking here.